Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss about the Stokes theorem, which comes under vector integral theorems. The Stokes theorem is a transformation between line integral and surface integral. Already we have seen two more theorems in the previous classes. One is Gauss divergence theorem and other one is Green's theorem in a plane. Green's theorem also a transformation between line integral and double integral, but it is transformation between line integral and surface integral. Both are double integrals, but here the surface integral means it is equal to integral some function dot n bar ds. And you know that line integral means integral over any curve C. The integral evaluation along the curve C is known as the line integral, which is denoted by integral f bar dot dr bar. So Stokes theorem defines a transformation between the line integral and surface integral. Now see the statement of the theorem. Let S be a open surface bounded by a closed non-intersecting curve C, and if f bar is any vector, differentiable vector point function, then by this theorem, integral over the closed curve C, f bar dot dr bar, where f bar is the differentiable vector point function defined on this dr bar, this is dxi bar plus dyj bar plus dzk bar, is equal to integral along the curve C, curl f bar dot n bar into ds, where f bar is the differentiable vector point function, and curl f bar you can calculate. Curl f bar means it is a vector point function which is obtained by finding del cross f bar. Already we have seen in the previous classes, curl f bar is a del cross f bar. This is determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and the last one vector f1 I bar plus f2 j bar plus f3 k bar, where f bar is, so I bar coefficient f1, j bar coefficient f2, k bar coefficient f3, where C is traversed in the positive direction. Positive direction means anti-clockwise direction. This is the positive direction of the C. That means the curve is, we have to evaluate along the anti-clockwise direction, and n bar is the outward normal vector or unit outward normal vector to the surface at any point of the surface, yes. So this is the statement of the theorem. So let S be any open surface bounded by a closed, this is surface, and this is bounded by this, like this. It is a closed non-intersecting curve C. If f bar is any differentiable vector point function, integral over the closed curve C, f bar dot dr bar is equal to integral over S curl f bar dot n bar ds, where C is in the positive direction and n bar is the unit outward normal vector to the surface, yes. So now I am considering this for Cartesian curves. Suppose if I consider Cartesian curve, that f bar is f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are continuous and differentiable functions of x comma y comma z, and n bar is the outward normal vector, makes an angle alpha, beta, gamma respectively with the positive direction of x, y, z. Then n bar is the unit outward normal vector I bar cos alpha plus j bar cos beta plus k bar cos gamma, and f bar dot dr bar. F bar means we know that what is f bar? It is f1 I bar plus f2 j bar plus f3 k bar dot dr bar. What is dr bar? That is dxi bar plus dyj bar plus dz k bar. then f bar dot dr bar is equal to f1 dx plus f2 dy plus f3 dz. So this is f bar dot dr bar, already here I have written directly, and n bar is the outward normal vector to the surface. Then curl f bar means already I told you del cross f bar, determinant of I bar, j bar, k bar, dou by dou x, dou by dou by z, del I bar coefficient dou by dou x. What is del means? Del means what? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Here I bar coefficient is dou by dou x, j bar coefficient dou by dou y, k bar coefficient dou by dou z. And the last row f1, f2, f3, where f1, f2, f3 are functions of x, y, z. Now on explaining this, we will get I bar into, on discarding the first column and first row, dou f3 by dou y minus dou f2 by dou z. Minus j bar into, j bar this is, on discarding this column and this row, dou f3 by dou x minus dou f1 by dou z. Dou f3 by dou x minus, so this will be the, in the reverse model. So here dou f3 by, or you can put dou f3 by dou x minus j bar into dou f3 by dou x minus dou f1 by dou z. The last element k bar into plus k bar into dou f2 by dou x minus dou f1 by dou y. This is okay. So here minus and plus alternatively will get changed. Therefore curl f bar dot n bar. Curl f bar is, this is dot n bar. Dot n bar means we know that in the previous slide, cos alpha I bar plus cos beta j bar plus cos gamma j bar k bar. On making dot product of the two vectors, what we will get? Dou f3 by dou y minus dou f2 by dou z of cos alpha minus dou f1 by dou z, or you can reverse, you can write it as reverse side. Dou f3 by dou x minus dou f1 by dou z cos beta plus this one into cos gamma. So in the Cartesian form, curl f bar dot n bar is equal to this one, and integral over f bar dot dr bar, that is integral f1 dx. Here I can write integral f bar dot dr bar. Already we have written here. I will show it. Integral f bar dot dr bar. This is f1 dx plus f2 dy plus f3 dz. On making these two as dot product, what you will get? Integral over the closed curve C. This is integral f bar dot dr bar along the closed curve C. That means f1 dx plus f2 dy plus f3 dz. And the right side hand side, it is integral over S. This means it is a double integral. Dou f3 by dou y minus dou f1 by dou z, dou f2 by dou z of cos alpha minus, and this will be minus and plus, you will get alternatively cos beta plus this one dou f2 by dou x minus dou f1 by dou y of cos gamma into ds. What is ds? ds means dx into dy. Suppose if you consider the projection in xy plane, ds is equal to dx into dy by magnitude of n cap dot k bar. Suppose if you consider the projection in yz plane, then ds will be dy into dz by magnitude of n bar dot, and if it is yz, then it is I bar. So if ds is zx plane, then dz into dx by magnitude of n cap dot j bar. So these are the three different forms based on the projection. So clearly this is x axis, y axis, z axis. If you consider the projection on xy plane, then the shade will be like this, and the formula for area ds will be dx into dy by magnitude of n bar dot k bar. Like that you will get. Suppose if you consider the projection of this surface in yz plane, then the formula will be like this. Suppose if you consider the projection in zx plane, this is the projection, the shade of this one, then the formula ds is equal to dz into dx by magnitude of n bar dot I bar. So n bar dot I bar is clearly, that is the dot product of the two vectors, where n bar is the unit outward normal vector. So this is the, therefore the formula will be, this is equal to this one. This is according to the Cartesian form of the given Stokes theorem. So now I would like to solve one problem, verification problem. So in this also you have verification problem of Stokes theorem, and based on applying Stokes theorem, if you have line integral information, you can find the double integral value. Similarly, if you have the double integral means surface integral value, you can find the line integral according to the Stokes theorem. So what is the Stokes theorem? First we write integral along the closed curve C, f bar dot dr bar is equal to double integral curl f bar dot n bar into ds. This is the relation between line integral and surface integral. This is the by Stoke's theorem. So first you see the Stoke's theorem. Integral over the closed curve C f bar dot dr bar is equal to double integral over S curl f bar dot n bar into ds. Now here what is the given information? F bar is the vector point function. So given 2x minus y into I bar minus z square y j bar plus y square z into k bar. Taken over the upper half of the surface of the sphere. So we know that how to represent the sphere. Upper half only. Upper half means only the curve is, the surface is like this only. Upper half of the sphere. So full sphere means this is sphere, it is like a ball. Upper half of the sphere means this is semi sphere. And the x square plus y square plus z square is equal to 1. What indicates this equation? So x, the radius is 1 comma 0 comma 0 or 0 1 0 0 0 0 1 like this. Suppose if you consider this on yz plane, then it is yz plane. Then on the y-axis it is 0 comma 1 comma 0. So this is the circle bounded by the closed region C. This is the circle. So this will be on xy plane. The closed surface. This is the surface. Open surface, but it is this closed curve. This will be along this surface will be the xy plane, on xy plane, right? So now first we see integral f bar dot dr bar. First evaluate, consider what we have to consider: integral along the closed curve C f bar dot dr bar. So f bar dot dr bar means f bar is given that it is a 2x minus y I bar minus z square y into j bar plus y square z into k bar. This is f bar. And what is dr bar? Dr bar is dx I bar plus dy j bar plus dz k bar. Then what is f bar dot dr bar? The dot product of the two vectors. That is 2x minus y dx plus of minus. So I can write minus sign here. Minus z square y into dy minus z square by dy plus y square z dz. This is f bar dot dr bar. But because the surface is defined in the xy plane, upper half of the surface, the projection is considered on xy plane. So on xy plane, what we will get? Z is equal to 0. On xy plane, z 0. So that dz is equal to 0. This is f bar dot dr bar. But if you consider the projection on xy plane, the surface projection on xy plane, then the value of z is equal to 0 and dz also 0. So z is 0, dz 0 means then f bar dot dr bar, what it will become? F bar dot dr bar, second term complete 0, third term also complete 0. So you will get only 2x minus y into dx. F bar dot dr bar is 2x minus y into dx. Now I will write here integral f bar dot dr bar along the closed curve C is equal to integral. So what is the, after 2x minus y into dx or the closed curve C. So what is the closed curve? The closed curve is a circle. So if you want to write the equations, x is equal to r cos theta and y is equal to r sin theta, and theta varies from 0 to 2 pi. So in this way you can find the integral over the closed curve C value. Integral over the closed curve C, what is the value? 2 into x means r cos theta, y r sin theta into dx. 2x minus y, 2x minus, so previous slide I will see. So what is x is equal to? R is equal to 1, radius is equal to 1 here. X is equal to cos theta, so y also sin theta. So we can put r is 1, so 2 cos theta minus, you can write it as 2 cos theta minus sin theta into dx. What is dx? Minus sin theta d theta. Minus sin theta d theta. but theta varies from 0 to 2 pi. So here integral 0 to 2 pi. So you can take minus sign outside. 2 cos theta sin theta first term and minus sin square theta d theta. So minus integral 0 to 2 pi. So 2 sin theta cos theta, it is sin 2 theta minus sin square theta. So first integral is integral 0 to 2 pi sin 2 theta d theta minus integral 0 to 2 pi sin square theta d theta. So what is the integration first term? Integral sin 2 theta means minus cos 2 theta by 2 between 0 and pi. So first integral value. Second integral value sin square theta can be written as 1 minus cos 2 theta by 2. So this is integral 0 to 2 pi 1 minus cos 2 theta by 2 of d theta. So on integrating, what you will get, I will see here. So minus minus plus first term 1 by 2 cos 2 theta upper limit 2 pi lower limit 0 minus of minus this also plus. So here the integration 1 by 2 into theta minus sin 2 theta by 2 between 0 and 2 pi. Am I right? So here minus of minus plus cos 2 theta by 2. So 1 by 2 cos 2 theta upper limit 2 pi lower limit 0 minus of minus plus again. On replacing 1 sin square theta is 1 minus cos 2 theta by 2. So 1 by 2 theta into integral d theta, theta minus cos 2 theta integration sin 2 theta by 2. So now on substituting the limits, cos 4 pi, cos n pi is, cos n pi formula is minus 1 whole power n. Cos 4 pi, that is equal to plus 1 and minus cos 0 also 1. So the limit value 0, but here 1 by 2 into, this is 2 pi minus sin n pi 0, lower limit entirely 0. That is equal to 1 by 4 into 2 pi, that is equal to pi by 2. So I'll check it out the answer later. This is pi by 2. What is the value of this one? So I'll check it out the value. Integral f bar dot dr bar 0 to 2 pi 1 minus cos 2 theta by 2 minus theta by 2 here. Theta by 2 upper limit 2 theta, lower limit 0 and lower limit 0 here sin 0 0. So 2 theta by 2. So I will, where is 1 by 2? This is not there only. So this is 1 by 2 into 2 pi, that is equal to pi. So now once again I will explain. Integral over the closed curve C f bar dot dr bar. F bar dot dr bar only will get the 2x minus y into dx as per the previous slide. So on xy plane, the projection is considered as on xy plane. So z0, so that dz 0. So z0 means second term 0, third term 0, complete only first term you will get the value. The first term is 2x minus y into dx. So on replacing, this is integral f bar dot dr bar by 2x minus y dx over the closed curve C. But theta limits here 0 to 2 pi because the circle in it is theta varies from 0 to 2 pi. So 2x means r cos theta and y r sin theta, but r is 1. So 2 cos theta minus sin theta and dx is minus sin theta d theta. So on writing outside is theta, d theta. So 2 cos theta sin theta minus sin square theta d theta. 2 cos theta sin theta is replaced by sin 2 theta d theta minus integral 0 to 2 pi sin square theta d theta. Already one minus term is there already. 2 cos theta sin theta minus of minus plus sin square theta. On taking out minus sign, you will get minus sin square theta. So now sin 2 theta d theta is equal to integral cos 2 theta by 2 minus sin 0 to 2 pi minus, but sin square theta you cannot integrate directly. We have to reduce this into the form 1 minus cos 2 theta by 2. So you don't have any formula for sin square theta for 0 to 2 pi limits. So we write the sin square theta as 1 minus cos 2 theta by 2 d theta. So the first integration minus of minus plus cos 4 pi. That is 1. Lower limit also 1. Cos 0 1. And 1 by 2 is there. 1 by 2 into 1 minus 1. That is entire term is 0. This entire term 0. Only plus. Second term 1 by 2 into integral d theta. That is theta between 0 and 2 pi. So you will get 2 pi only. Second term cos 2 theta means sin 2 theta. That is entire term sin 4 pi 0. Sin 0 also 0. Only 2 pi by 2 will get. So final value pi. This is called equation number 1. Integral f bar dot dr bar value is equal to 1. Now we consider curl f bar. What is curl f bar? Curl f bar means del cross f bar. Del cross f bar means I bar, j bar, k bar, and it is dou by dou x, dou by dou y, dou by dou z. And what is f bar? What is f bar? I bar coefficient 2x minus y. 2x minus y. I will retake 2x minus y minus z square y. I think second term minus z square y. Already I have written here minus z square y. And last term y square z plus y square z plus y square into z. So I bar into, so this is dou by dou y of this one, that is 2yz minus of minus dou by dou z of this one. This is also 2yz. I bar into, see this, I bar into dou by dou y of y square z, that is 2yz, dou by dou z of this one, minus of minus plus dou by dou z, that is 2zy. Similarly, minus j bar into dou by dou x of this one 0, dou by dou z of this one, that is also 0, plus k bar into, on discarding this column and this row, dou by dou x of this one 0, dou by dou y of this one minus of minus 1. So this is equal to I bar into 2yz, I bar into, this is 2yz minus minus of minus plus 2yz minus of minus plus k bar. So this is, once again I will check it out, 2x minus y. I'll check it out, 2x minus y, what is the value? 2x minus y value minus z square y minus y square z. So I bar into minus, I bar into, so this I will check it once, minus. So this value becomes minus 2yz, this is minus 2yz, this is 0 plus k bar. So this curl f bar is equal to k bar. Then integral, what is our formula? The right hand side is integral curl f bar dot n bar into ds, that is over s. That is integral over the surface s. Curl f bar means what? K bar dot n bar into ds. But what we know that in surface integral evaluation, ds is equal to dx into dy by magnitude of n bar dot k bar if you consider the projection in xy plane. Or I can write it as k bar dot n bar ds is equal to dx into dy. K bar dot n bar into ds is equal to dx into dy. So this is dx into dy. Am I right? Dx into dy. Suppose if you consider the projection in xy plane. In xy plane what it is? 4 into. So this is 4 into what are the limits of integration? The region of integration x0 to root minus y value, y0 to root 1 minus x square, and x varies from 0 to 1, and first it is dy into dx. If you consider, I'll tell you, we consider the surface is the circle on xy plane. Xy plane means like this is xy plane circle like this, but I consider it is the first part of the circle, first quadrant of the circle. So here x-axis, y-axis, on considering the strip parallel to y-axis, y0 to root of 1 minus x square, that is the limit, y0 to root 1 minus x square, and x varies from 0 to 1, and this is one area of the quadrant. So to get the full area, we have to multiply with 4, 1, 2, 3, 4. So 4 into 0 to 1, integral 0 to root 1 minus x square dy dx. So on integrating, what we will get here, I evaluate, this is 4 into integral 0 to 1. So integral dy means y between 0 and root 1 minus x square of dx. So there is 4 into 0 to 1 root 1 minus x square into dx. So this value is equal to, entire value is equal to pi on evaluating. So therefore on the first case also you'll get the value of the first integral is pi, and this is also pi. That means what? The Stokes theorem verified. So what is verified is integral over the closure curve C, f bar dot dr bar is equal to integral along the surface curl f bar dot n bar into ds. In this case, the projection is considered on xy plane. So the projection is taken in xy plane. So we have proved this value is equal to pi, and this is also pi, and both values are one and the same. So the result, the given problem is verified the Stokes theorem. Here you can put, suppose if you want to evaluate x is equal to, you can put sine theta, x sine theta, 1 minus sine square theta, cos theta. You can use the substitution method, or you can directly write pi. So 4 into, how you can write x is equal to sine theta, then dx is equal to cos theta d theta, or direct formula also you can do that. Root of a square minus x square. Integral root of a square minus x square, or x sine theta dx cos theta d theta. When x is 0, sine theta 0, theta also 0. This is pi by 2, root 1 minus sine square cos theta, and dx is equal to cos theta d theta. So cos square theta, integral 0 to pi by 2 cos square theta d theta. So I'm writing 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2, 1 by 2 into theta plus sine 2 theta by 2 between 0 and pi by 2. So on substituting the limits and on evaluating, this value will be pi. So that will be the required. Here we will get 4 into 1 by 4. 4 will get cancelled, and the value is equal to pi. So this will be the integration of the this simple root 1 minus x square under dx between x is equal to 0 to 1. So there ends the Stokes theorem verification. So this reference of this problem is Mathematical Methods by S. Chand, 2006 publishers. See this, and already I have given in here. It is a small, I'll show it. This is one. Here I have put it as a reference, and the book, the problem is taken from the book by Mathematical Methods of the edition of 2006 by S. Chand publishers. And if you want, you can verify that problem in that book also. So, thank you.
Like, share and subscribe. Hit the bell icon for more updates.